Hey guys, this video is going to be optional. It's on 8A.4, and I'm going to be going in and doing these practice problems with you. Feel free to pause the video at any time to try the problem on your own, and then check in with me to see if you have it correct. Let's go and start. 2/3 is a 0, and I want to find all the other remaining zeros of f of x. If 2/3 is a 0, I'm going to use synthetic division on the polynomial to see what the resulting polynomial is going to be, and then I'm going to take that resulting polynomial, set it equals 0, and solve for x to find the other zeros. Let's do 2/3 times 48. That's going to be 16 times 2, which is 32. I have a negative 80 and a positive 32. That will give me a negative 48. A negative 48 times 2/3 is going to be negative 32. And I didn't mention this before, but you are welcome to use a calculator if you're struggling with this math. 41 minus 32 is a 9. And 9 times 2/3, that's going to give you a 6, which gives me a 0, as expected. Because it told me that x equals 2/3 is a factor of 48x cubed minus 80x squared plus 41x minus 6. Okay, so the resulting polynomial here was 48. Remember, we started with x to the third, so now I have x squared minus 48x to the first plus 9 equals 0. Now I do notice that I can take a 3 out of each term, so I'll go ahead and do that. I have 16x squared minus 16x plus 3. And at this point, I could try to factor, or I could try to use quadratic formula or completing the square. Let's see if factoring will work. Sometimes it works, sometimes it doesn't. Oh, excuse me. Factors of 48, 1 and 48, 2 and 24. I'm looking at the things that added to 16. I got 3 and 16. That's not going to work. I got 4 and 12. Hey, minus 4 and minus 12 gets a negative 16. Let's try it. Let's do some splitting the term. Oh, Mr. Lakin, we love splitting the term. That's great. All right, we can take a 4x out of this guy, and then we'll have a 4x minus 1. And then if I take a negative 3 out of this guy, I'm also left with the 4x minus 1. Just a note, I could take a positive 3 out, and if I did take a positive 3 out, it would be a negative 4x plus 1. But then I need 4x minus 1 to match up with the second factor. So that's why I took out a negative 3 versus a positive 3 here. Our final part in factor form is going to be 4x minus 3 times 4x minus 1 equals 0. And if I said those factors equal 0, I get x equals 3 over 4 and x equals 1 over 4 by setting each of these factors equal to 0 and solving for x. Those are my remaining factors. Yay, we solved the problem. Woohoo! Let's go on to the next one. So we have 2x cubed minus 4x squared minus 15x plus 5 divided by x squared minus 2x plus 1. And I'm not going to be able to do synthetic division here because that's just going to be not fun at all. So, well, that's unattractive. Excuse me. I'm going to do polynomial long division. And I'm not trying to say that my videos are putting me to sleep, so please, Brandon, I know you were thinking that. It's not true. Brandon Yip, for those people that don't know. Shout out to Brandon Yip. We got 2x cubed minus 4x squared minus 15x plus 5. We're going to do some polynomial long division of x squared minus 2x plus 1. Let's knock it out. X squared goes into 2x cubed. I did this before, so I'll do it again. And I get 2x, which means 2x is going to line up with my x to the first term, so I'll put a 2x here. And I'm going to distribute this 2x to everything that is the divisor. So we get 2x cubed. We get a minus 4x squared and we get a 2x plus 1, which is going to be a positive 2x. But anything underneath here, I have to subtract, so this is going to be a minus 2x cubed. It's a minus minus, which is a positive 4x squared, and a minus 2x. Okay, I get those cancel, and I get negative 17x plus 5. And I can't put x, I can't see how many x squareds go into x because the divisor is bigger than my dividend for the degrees on both, which means, my friends, that we have plus negative 17x plus 5 over x squared minus 2x plus 1. All done, and I'll write it clearly down here. I bet you thought this problem was going to be a tough one, didn't you? Look at this. This wasn't that bad. Done. Next problem. Let's use synthetic division to find all factors where root 3 is a factor. Oh, interesting. Now, if root 3 is a factor, it looks like I'm going to have to do this. And that's going to be weird, but let's try it. Let's do a 1, a 2, a negative 3, and a negative 6 for the synthetic division. And let's see what we get here. It should work out. We have 1. We'll multiply this by root 3, and that's going to be 2 plus root 3. Uh-oh. Now we'll multiply root 3 times this guy, and we get 2 root 3 plus 3. Now notice the 3's cancel. Oh, look at that. So we're just left with 2 root 3. And how convenient when we multiply root 3 times 2 root 3, we're going to get a positive 6, which gets us a 0. Now, that's good news and bad news for us, because now it looks like we're left with, remember this 1 is going to be an x cubed, but knock down one exponent, one power, so it's going to be 1x squared plus, that's a 2, plus 2 plus root 3, and that's an x, plus 2 root 3, and that's equal to 0 because we still need to find the rest of the factors. This does not look fun. But I think that we shall be able to end this okay, though, because I believe that if it is supposed to be in factored form, we can put an x here and an x here. It looks like we're going to need factors of 2 root 3, which should be 2 and root 3, and if I add those up together, I do indeed get 2 plus root 3, which is what I want. So I'm going to put a positive 2 here, I'm going to put a positive root 3 there, and let's just double check this, because this was kind of weird. I'm just going to check on the side here. I get x squared plus root 3x plus 2x plus 2 root 3, and the root 3 plus 2 is right there. So I am good to go, and my goodness, that was a tricky one. Now, now let me go ahead and finish up the problem here. To find the roots, I'll set x plus 2 equals 0, and I get x equals negative 2. I'll set x plus root 3 equals 0, and I get negative root 3. There's my remaining zeros. Now, it does say to find the factors, which means that the factors, I did too much work here, guys. So I checked the problem, it said to find all factors. So let me cross out this part in red, because that would not be the answer. It's going to be this part in green, are the rest of the factors. Next problem. Given x plus 3 is a factor, write the function as a product of linear factors. Okay, x plus 3 is a factor. Let's use synthetic division. I got a 1, 3, negative 48, negative 144. This is a good time for you to try this problem on your own, and let's see if we get the same answer. Feel free to pause the video now. Here we go. We got 1, we got negative 3, and 0, and negative 3 again, and negative 50, and I'm sorry, it shouldn't be a negative 3 here. It should be a 0, which gets negative 48 if you weren't sure what I was doing. Negative 3 times 0 will be a 0. Duh, Mr. Lakin. And the negative 48 and 0 gets negative 48. Multiply those two numbers together, and I get a positive 144, which does indeed get me 0. Now that means that my resulting polynomial is going to be x cubed, but marked down a power, which will be x squared. It doesn't look like there's going to be any x term here, so it will be minus 48. No remainder equals 0. Now let's see, I'm going to move the 48 to the other side, so I get x squared equals 48, and if I take the square root of that, I get x is equal to plus and minus. Now let's see, 48 is 16 times 3, and the square root of 16 is 4, so it should be plus and minus 4 root 3. So that means my factors are going to be x minus 4 root 3, and I'm going to also get x plus 4 root 3. And the function, as the product of all three factors, is x plus 3 times those two remaining factors, and this is equal to the same function that we started with, f of x. You're welcome to multiply those out to verify on your own. I like this stuff. This stuff is fun. Last problem. Express the function in the form this, and then demonstrate that f of k equals r. Alright, so let's go ahead and do So keep in mind that if I have some k, and I'm trying to plug that into the function, then I can actually use synthetic division here. So I'm going to do 1/5 as synthetic division. I'm going to do 10, a negative 22, a negative 3, and a 4. I don't need a placeholder. And let's see what we end up getting. We got 10, a fifth of 10 is 2. That's going to be a negative 20. That's going to be a negative 4. Negative 20, that's going to be a negative 4. That's going to be a negative 7. That's going to be negative 7 over 5. And 4 multiplied times 5 over 5 is 20 over 5. And I get 13 over 5. Is that when I take 10x cubed, let's write this in red, when I take 10x cubed minus 22x squared minus 3x plus 4, and I divide it by x minus 1 over 5, I get, I don't know why it went down there, sorry, I get 10x squared minus 20x minus 7, and then plus 13 over 5 divided by the divisor, x minus 1 over 5. Now let's answer the rest of the problem then. It says to verify, to demonstrate that f of k is equal to r, and k is equal to 1/5. So here's what we're going to do, and I did this a little bit earlier before. I'm going to multiply everything, both sides of the equation, by x minus 1 over 5. What happens on the left is those cancel, and what I get on the left is this function 10x cubed minus 22x squared, which is actually f of x. On the other side, I get that quotient times x minus 1 over 5 plus 13 over 5, because those cancel. When I plug in f of 1 over 5, I get a 0 here, I get equals 13 over 5, and verified. Thanks for watching.